compute its angular velocity, omega, after its center has moved a distance of 3 meters up the incline. The wheel has a mass of 40 kg with center of mass at O and has a centroidal radius of gyration of 150 mm. Determine the power input from the 100 Newton force at the end of the 3-meter motion interval. Okay, so the required in the problem is the power input, no? Meaning we have to convert this 100 Newton into power. Okay, so power and force are somewhat related, no? Because without force there will be no power. Okay, but it's not only force that makes up the power, no? Should be like multiplied by, just like when you see work, work is force times distance, so you have to multiply force and distance in order you have a work, no? The same also with power. So you have a force, then you have to multiply it with something. So that something is remains to be seen, no? That depends upon the definition of power. Okay. But I guess there is that formula, no? But the most important there is the 100 Newton. Okay. Okay. And maybe the other one is based on the dynamics of the what do you call this uh wheel, no, wheel. Okay, so if you look at the figure, this is the one, no? So you have a wheel. So supposedly with this incline, if there is no force on the cord, this one will roll down, no? But it will not, because there is that cord wrapped around on the outer rim, and then in fact it is being pulled up, no? the the direction of the force is parallel to the surface of the incline. So if the incline is 15 degrees, the 100 Newton force is also 100 degrees with respect to the horizontal. Okay? So the diameter of the outer rim is 200 meter. The diameter, no, the radius, I mean, the radius of the the bigger disc, no, for the outer rim is 200 mm, while the radius of the inner rim, okay, is 100 mm. Okay, so we have to draw the free body diagram of the wheel here, no? So that we will understand. So as we know, the wheel rolls up without slipping, and I think it says here that after its center has moved a distance of 3 meters up the incline, meaning O, this point O moves by 3 meters up, no, 3 meters up. Okay, so 3 meters up. Okay, so this is the free body diagram class. Okay, you have the wheel, no, the wheel that is composed of outer circle and an inner circle. This outer circle represents the outer rim, no, which has 200 mm radius. So bali ang diameter niya ni may muna ni siya 400. Okay, we are talking about radius man yung 200, so diameter is twice the radius. Also, the diameter of the inner circle here is 200. Okay, now it is stated in the problem that the center is O, no? Now, if we leave A as the point of the tangent line of the chord, so meaning perpendicular to the plane passing through O and A, so OA there is equal to 200. Okay, and OC is 100 mm. So meaning CE equals 300 mm. Okay, so here the geometry is being drawn, no? Being drawn here. So you have this line here to this is 300 mm. Okay, now Why it is 300 mm? Because you have 100 as the radius, this one, and 200 here, no, 200. Okay, so that means that this is 300. Okay, so you see this green arrow labeled as the V and VE or V sub A. Now, V is just the velocity of the center, no? The velocity of the center, line O. So, while V is the velocity of point A. Now, if we can solve V, we can also solve VE because VE is just uh what we call that function of B, no? In fact, it can be solved by ratio and proportion. Like for example, if V has a 100 mm distance from C and A has a distance of 300 mm, meaning if V is 1, then V is 3 uh, because it is 300 three times the distance away from B is, no? So that means that whatever the value V is automatically three times by the reasoning of the distance, the multiple no the distance, no, with respect to the distance of A, and it so happened that OA is three times the distance of OC. Okay. Now on the I am talking about free body diagram. So kung mag-double at free body diagram, you should show all the force that is involved there, no? That is involved. So first force is the 100 Newton. So this is the reason why the the wheel rolls up, no? Without 100 Newton, I don't think so that it will roll up. It will roll up. It might be that by virtue of gravity it will just roll down. Okay, but the problems state that there is under 100 Newton and that U moves by 3 meter. Okay, so there's that arrow, red arrow. Another red arrow is the gravity. No, this 392 Newton. Now, if you notice, what is that 392? It's not given in the problem 392, but there is that 40 kilogram. So if you multiply 40 by 9.81, because kilogram is not a force, that's a mass. 40 times 9.81. Supposedly 392.4, no? Pero the author here feels lazy to write the decimal point. So you just write 392, no? Doesn't matter because 0.4 over 392 is just very small, no? 0.4 that amounts to 0.4 divided by 3, 0.4 divided by 3.92. So that's only 0.1, 0.1%, 0.1%, okay? So that represents the 392. And why it is acting at O? Because it says that uh, it has a mass of 40 kilogram with center mass at O. So it should act at O. And it is downward because it is a gravitational force. Now, the two other force acting at C are just the reaction, the normal reaction of the what do you call this, the 40 kilogram wheel. Okay, 40 kilogram wheel. So there's that N. And there's that F because without F, this one will just slide down, no? So there is a friction, no? There's a friction between point of contact, no? So it will not just slide down. So there is that F, okay? And if we are going to recall our uh, Coulomb friction, that is equals to mu times n. Okay, F is equals to mu times n. That's how we view the equation of friction. That's equal to mu, the coefficient of friction, multiplied by the normal reaction, which is n. Okay, but we don't have to. We just label it as F and n. Okay, so uh, in this case, uh, there are only two forces that makes work that does work here, no? The one is the 100 Newton okay, which move uh, along the incline A at A. So if you have force and then you have a distance of travel, and you multiply the two, that will become work. And the other one is you have the 392 Newton from this distance. So that will be that will do also work. Okay. So in other words, the work done, no, the work done here is equal to work done from 1 to 2 is equal to 100 times 9. Okay, this 9 is okay. This 9. Oh, wait, 9. Okay, so uh, there is it. No, C is the instantaneous center of zero velocity. So this is the instantaneous center of zero velocity. The velocity of A, BE is equals to 200 times 100 divided by 100 B. So that's 3V. So 3 times of V. Okay, that's BE. That's what I told you a while ago, that VE is 3 times V. No, by the reasoning of the distance away from from V. No, it is 3 times farther than the position where V is. So whatever velocity B have, V should have 3 times the velocity. Okay, so that's why V equals to 3V. Now, point A on the chord moves a distance of 200 mm plus 100 mm, that's 300, divided by 103 times of that O. Now, it says here in the problem that uh, okay, the distance traveled. No, yeah, if we are computing the distance traveled, if V travels by 3 meters, 3 meters already. Okay, 3 meters already. That means that the E also travels by 9 meters. So given man, no given. Here, I will say here. So, given okay, O travels 3 meters along par parallel parallel to the incline. Okay, incline. So that's the one. So it also say that A. So therefore, A travels 9 meters parallel to the incline. So the explanation is like this. The explanation is like this. I'm going to do the explanation. Okay, so first I drew the incline. How to do the incline? Magdulo the incline. Ini siguro, no? Here we have the incline here. Explanation in click. Okay, so this is the incline. Okay, that's the incline. Okay. Tapos yung pala yun. 15%. Okay? And then I drew the point O here. This is a, I will do line. Okay. Okay. One of that is O. Kana to ang O niya din. Muna siya ang O. Okay, muna siya ang O. Kanya, upyahon din ako na siya. Copy, paste. Mao ni siya ang A. Ang A. Okay, muna siya ang A. So, ako na siyang kutangan. Na mao na siya ang A. Kanya, kinili mo na siyang O. Okay. The problem is saying nga, ang U kuno, ang U, dili ulo ha, U. U. Travels 3 meters. No, so, travel siya by 3 meters. 3 meters sa noon. Okay. Matulan na usabon ang pulo na. Pula. Okay. Una siya travel. Butang na ito na, ay, siya siya. Dalawa siya. So, travel siya by 3 meters. Ingon sa problem. Okay. So, kung ato na siyang evaluation proportion, sumundo tali ni og line. Ang pangutana, kung pila ang natabil sa A, so makita nato na siya. So, mo ni siya ang natabil sa A. So, nahimo din na siyang 9 meters. 9 meter. Okay. Anong 9 meter man? Kay 3 times OA is 3 times man from this is C here. C na siya dito. C. What's yung C? Okay, wala maklaro. C. So, labing ko hawan niya ang field. Okay, naman na siyang C, no? So, AC is 3 times OC. So, this is 3 meters, this is 9 meters. Okay. So, the work done from 1 to 2, from this 1 to 2 is equal to 100 times 9. Okay, this is the work done minus 392 times sine of 15 degrees straight. So, this distance from here to here because mo ko din. Ini siya mao ni siya force. Force na siya. So times 9 meter that constitute a work 100 times 9 and about C it rotates in a clockwise manner, no? So ako lang siya nakuha. Okay. So okay. So the work done there is 100 times 9. It's positive because it moves opposite to the other one. No? The other one is still moving. This one here. That's vertical. Okay. So the vertical component of this one the vertical component of this one. How do you compute the vertical component of that? That is 3 times sine of 15, no? Sine of 15. Okay? You're going, that's the force. You're going to consider the force parallel to it, parallel to that. And the force parallel to that is this one, going there. Okay? So, mauna siya. Kung ako siyang, akong tanaw na siya din, ako na siyang enlarge. Kung ako na siya enlarge, mo nang mahitabo. Mauna siya. Okay. So, kita ni mo na siya. Oh. Kini siya mo ni siyang gitawag og 392, while this one is 392 sine of 15 degrees, no? Sine of 15 degrees. When you are calculating work, the force should be parallel to the distance traveled, okay? And since this is gravity, 392 is gravity, it acts vertically. What we need is to find the component of this 390 force that is parallel to the incline. And that is just a very fraction, small fraction, no, this one. This is 392 sine of 15 degrees. Okay, this is 392. So, the work done there is 392 sine of 15 degrees times 3 meter. Okay, so the sum of the two is 595 joules. Joules here is just a unit. That unit is equivalent to Newton meter. Joules is Newton meter. No, it's just a unit named after the person who is a mathematician. I do not know what is his name, but his family name is Joules. It's just like Pascal. Pascal is just a scientist, and just to immortalize him, his name is used as a unit, no? Unit. So, Kim's nagyapo si Watt, no? Si Newton, mo gyapo, no? But Newton is just kilogram meter per second squared. That's the tawag niya anak ng generic unit. Okay. So that's the work done. No? That's the work done. Now, when we are solving this problem using work and energy method, so mauna siya ang equation, no? Mauna siya ang equation. T1 meaning the kinetic energy at point 1 plus the work done from 1 to 2 is equals to the kinetic energy at 2, no? So kinetic energy at 1, that is the initial, no? 1 is here. 1 is at point 2. And the point point 2 is after the center of the wheel moves by 3 meters along the incline. So at that instant, the wheel is already moving. It's already started moving. While at start at 1, the wheel is still at rest. So in fact, the problem here, nagingon siya nga starts from rest. So T1 is 0. So in this equation, in this equation, work and energy, T1 is plus U12 equals to T2. State that this is the kinetic energy at point 1 plus the work done from point 1 to 2 is equal to the kinetic energy at point 2. Okay. So T1 here, T1 is 0. So it's here, no? 0. Okay. Now U12, we already solved it, and that U12 is 595 joules, no? So U12, I will write it here. I will write it here. T1 is equal to 0. Okay. Started rest. Started at rest. Okay. So that's one. I will. And you want to is equals to 595 joules. Okay, or that is Newton meter, no? Newton meter. So this is the work done from 1 to 2. So work work done from point 1 to point 2. Okay. How about T2? T2, Tito muna siyang lalaki sa tita. No? So, dili. Tito. Tito. Sa ba na sa English ang tito? Uncle. Uncle. Okay, Tito is equal to the kinetic energy at point 2. Okay. So, but by this time, the wheel has already moved, have moved already, no? So, yeah, that's it. Kinetic energy at point 2. So, at point 2, the wheel is already moving, no? Moving, okay? So, it has moved already. Now, what is the T2, no? The kinetic energy, so for general motion, no? General motion, okay? Before, I mentioned that there are two kinds of motion, okay? One is translation, and the other one is rotation. Now, if you try to imagine how the wheel moves, it's not the move. This wheel is rolling up, no, meaning at the same time that this one travels along the incline, the wheel is also rolling. So this is a general motion. It's not just a plain sliding. No? This is just a block push along the incline. So there's no rotating body there. But this one, since there is no sliding, so the wheel just move by rolling. Garol na siya. So as the wheel travel along the incline, at the same time nag-roll sad ang rigid body. So dunay pag-roll niya duna na siya inertial force. At the same time duna sad siya translational force. So in other words, T1 at T2, the kinetic energy at point 2 is T2 equal to 1/2 mb squared. That is for the rotational transitional work, transitional energy, no? Or the transitional one. We'll just say small m for the mass. Okay. This is the kinetic energy. Kung walay rotation, tabi kinaka may rotation, so butangan sa limon siya og I omega squared. Omega squared. Okay, omega squared. Unsa man ang I? That is rotation, paano siya? Tawag ano niya? Moment of inertia, no? Rotational inertia. Rotational inertia. Inertia. And as even here, for a disk, for a disk, for that is equal to mr squared. mr squared. R squared. Okay. So substituting this to there, we will have substituting I mr squared to the equation of kinetic energy at point 2, it will become may muna siyang R squared there. R squared. Okay? But V is equal to R omega. Okay? Omega is the what we call angular velocity. So therefore, if I B equals to RW squared, so it will happen that B squared is equal to R squared omega squared. Okay? So let's say, paano? Yan lang kayo na i-subscript. Balag hinay. Okay. So, ang may tabo, kung ato ni siya i-substitute din may mo ni siyang T2 is equal to 1 half MB squared plus 1 half MB squared. O, yung ito na. Okay. So, I think nasolve ba na siya din? Omega din ang atong anon, dili pwede. Omega atong anon, no? So, ang aim na lang ato i-convert ang aim. Okay, mo na ni siya, no? So, ang B squared na lang kinilang ato i-convert into this. So, ang B squared equals to R squared. So, meron siya in R squared omega squared. Okay. Okay. So, we have P2. Okay, so ang computer na to ang T2 that is equal to this is 0.5 1 half times 40. Ang R squared to this is 0.1. So this will be 0.1 squared omega squared. So this will become squared. Then na kayo plus 0.5 just because ako yung squared mo. Squared. Then mass. The mass is still 40. 40. Then the radius, no? The radius. So the other one is 0.15. Muna siya ang giingon nga rotational radius of gyration of 150 mm, no? Sa kining gatuyok nga object, radius of gyration of 150 mm. So that's given. Okay. So doon na siya ay 150 mm din. So that is squared then omega squared. Okay. This one is squared. So omega squared. So here we have T2. We have T2 equal to 0.65 omega squared. 0.65 omega squared. Now we go back to this. We substitute T10.595 Newton meter and 0.65 omega squared. So we found out that the omega is 30.255 radian per second. Now we can converting what we call this angular velocity to linear velocity. Linear. So velocity is just equal to radius times angular velocity. So since we get already the angular velocity in radian per second, kan angular velocity usa siya ka kusog ni tuyok. Okay, usa siya ka kusog ni tuyok. Ang yung kakusog ni tuyok is 30.255 radian per second. If we are going to convert that to linear velocity, all we have to do is just to multiply it by the radius of that body. Now, the radius is equals to 0.3. So we're talking about A, the point A here. Now, which is 0.3 from meters from point O. So, the velocity equivalent to that is 9.076 meter per second. Muna ang iyang velocity. 9.076 meter per second. And power, power. Okay. So, power input is just equals to force times velocity. Okay. So, and force times velocity has a unit of Newton meter per second. So it has its power. No. Now the other way of saying the unit is by the unit watt. No, watt. So watt, how many watt, how many kilowatt? So kilowatt is a unit of power, or watt is also a unit of power. When we say kilo, mega, that's just a multiple in terms of thousand or maybe million applied to watt. So if you say 1,000 watt, you can say 1 kilowatt. No, that's equivalent to 1,000 watt. When you say megawatt, that is 1 million watt. So that's how unit is being stated. Okay. So, but the equation of power is just equals to force times velocity. No, and I know that there are other equation of powers in electrical engineering. No, so they have different expression of power. No? It's not just equals to force times velocity, but force times velocity is the power. Okay. So, kana dahil migo ka sa sumbag, no? Kana dahil sumbag, migo ka sa sumbag. Ma-measure nimo unsa ang power, no? Sa sumbag. Ang power sa pagsumbag is the force na iyang i-deliver, kunya ang velocity sa iyang pag-execute sa sumbag, no? Pag punch, no? Pag-punch. So the force, the impact force of the punch and the velocity of the punch. So the two constitute power. So if you multiply the force and the velocity of the punch, that's equals to power. So that's how it is. Pero ang power sa pwede sa ma-measure nimo by electrical means, no? Itong equation niya. No? I think power is equal to energy per unit time. Yeah, energy per unit time. So that's the power. Okay. If you multiply energy by time, that becomes work. So power in other way of saying is just equal to work per unit time. Okay. The rate of work, that's the power. Okay. So because we know the force is 100 Newton and the velocity is 9.076, so the power or the rate of work is equals to 9 o 7.659. So, I will just say rate of work, meaning this is equals to the differential, the, the first derivative of work is equals to the power. Okay. So, that's all for today class, no? So, maybe uh, the assignment, saan ba natin ha? Just study this problem class, no? Mauni siya. So, how it is being solved by work and energy method. So, it's quite interesting because when we set up the equation of kinetic energy, you can see that you use the complete formula, no? The general formula, wherein it involves the linear uh, energy, the work done by the kinetic energy for translation, and the kinetic energy for rotational body. No? The inertia times angular, the square of angular velocity is the formula for the kinetic energy of rotating body, while 1/2 mass times velocity squared is the kinetic energy of translating body. Okay, so that is why we say general motion. So I will include it here. So translation plus rotation. So if you add the two, it becomes general. Okay. So
Sir, apil ng kinematics agto sir ba? Kuan.
ha?
Nanay kinematics ater sir ba?
Yes, like kinematics. Kato na yung velocity. Velocity is
Okay.
kinematics. That's
Velocity
why
equals to
we,
ba to kuan sir katong W2 sir ba?
oh, ang velocity ato niya, given. Dala na mag-compute ang velocity. Kaya given naman velocity, actually. So, giingon man nga, ang, actually, ang distance traveled ang yata nito, 3 meters. Okay? So, find the angular velocity. But, you know, distance is just equals to velocity times time, di ba? Times time. So, or you can, the distance equals to, okay, if v is equals to s over time, so distance is equals to velocity times time. In the problem, the s is given, no? The s is given. So, the linear translation of point O is 3 meters. So, there's no need to solve the velocity at A, because A moves just a fraction of multiple of the movement of O. So if O moves by 3 meters, since A is farther from O, it moves 3 times farther than O. So that's why we have 9 meters, the distance traveled by A. Okay. We express that in terms of work done. Okay, because the two work, what we call that, exert force, but nagangi sila, no, nag-away sila, so one is positive, one is negative, but the positive win, no, positive is more, so that's why it moves up. Okay, so but the total work done, which is 100 times 9 minus 392 times sine of 15 degrees times 3 is equals to 592 joules. So in favor of the positive, so it goes up. Okay, so that's the work. So by work and energy method, using conservation of energy, it says that the work done, no, the work done from 1 to 2 plus the kinetic energy at point 1 is equal to the kinetic energy at point 2. So mo na siya ang ang input nato nga bago is the work and energy method concept, no. So katong formula nga T1 plus U12 is equals to T2. That is what we call the principle of work and energy, and it can be used to solve problems in dynamics. Okay, so problem in kinetics involves kinematics always because we always use the velocity, the distance traveled, the acceleration. So if dito ko tatakon sa kuan kini Newton's law because ang Newton's law nag-ingon man nga force equals to mass times acceleration. So acceleration unta pero minti atong gapangitaon, no? Now in this problem, ang gipangita power man unya power is equals to force times velocity. So we need to determine the velocity at point A. Okay, at point A. So using work and energy na solve na to. Okay. So nakuha nimo. nakuha nimo
Nakuha, sir.
okay.
Nakuha, sir. Nakuha, sir.
Okay. So thank you. Okay.
Thank you, sir.
So any other question?